Today we are going to talk about the challenges, practical challenges, and the best practices that we encountered while we evolved our data architecture at Meesho. Meesho is India's only true e-commerce marketplace. We were founded in 2015 by Vidit and Sanjeev. We've grown rapidly owing to our asset-light business model. In fact, we are the fastest growing shopping app to cross 500 million downloads. We contribute to 35% of India's third-party logistics order volumes. Our mission is to democratize internet commerce for everyone, and our vision is to enable 100 million or 10 crore small and medium businesses to succeed online. We are democratizing e-commerce for the underserved consumers and sellers by connecting them via our platform. Meesho is the most seller-friendly platform. We have a no-commission policy. We have a lot of tools which makes it super easy for sellers to get onboarded, to list their products. We are a democratic platform, so we don't have any tiering in terms of the sellers. We don't have private labels which compete with the sellers. Now on the consumer side, almost 5% of all Indian households shop on Meesho every single day. And this is due to the fact that we have a large unique assortment of almost 100 million plus products which are high quality and available at the lowest possible price. These products are a lot cheaper than the competition. So talking about the business scale at Meesho, in the last year we had almost 91 crore orders. In terms of the monthly active users, we've grown almost 2.5 times year over year. We cater to a unique set of customers, which is showing up in the data stats as well. Almost 80% of our orders comes from tier 2 plus markets. These are users who are probably interacting with e-commerce site for the first time. We had 140 million unique transacting users in 2022. We had a great sale event in the festive sale months of September and October. We had almost 10 crore orders placed on both the months. We had peaked out with around 8.5 million orders just in a day. We've seen similar stellar growth in terms of our sellers as well. There have been increase in the seller registrations, the number of sellers that come from tier 2 plus regions are also huge. Now talking about data and how it ties with the whole Meesho journey. In Meesho is a completely data-driven organization. Data is core to every business decision making that happens. Any change that happens corresponding to any user is based on the experiments that we run on the experimentation platform. Data is used to enrich the user experience across all the user groups, the sellers, the entrepreneurs, the consumers. So, let's say for example, in the homepage that we see, we have the feed that the user sees is personalized in a real-time manner. And all this is backed by data. On the category page, the ranking that we see, the way the products are grouped is all backed by data. The recommended products in the product page is again powered by a data product the growth in the business scale, we see similar exponential growth in terms of the data volumes that we deal with. In the last 1.5 to 2 years itself, the volumes have grown almost 100x. And the kind and variety of use cases that we deal with is growing every day. So how do we handle all that? And giving an overview on what a day looks like in Meesho for the data platform team. We cater to almost 100,000 ad hoc exploratory queries and visualizations and dashboarding queries that happen at Meesho. On a day-to-day basis, almost multiple petabytes of data are scanned to generate all the insights. We ingest multiple terabytes of data. And the number of events that we ingest on a day-to-day basis vary from 50 to 100 billion events on a day-to-day basis. We have upwards of 1,500 users who utilize our the data platform to solve their different needs. Being an e-commerce player, we have e-commerce specific nuances. Like there could be a successful sale campaign or a marketing campaign which requires almost 3 to 4x kind of a scale up in a few minutes. We see similar spiky loads on the consumption side as well. We have multiple users for to power all these use cases. Some of the use cases are the conventional ones, like providing out a visualization and reporting layer for looking at the metrics for the executives. We also power the product analysts and the business analysts who are analyzing out the metrics and also building out data products or data models, analytical models, which can be consumed back by the backend teams. Data platform also powers all the machine learning use cases and the data science use cases that power all the algorithms at Meesho. And this is done via a platform approach wherein we have a machine learning platform with multiple feature stores. And then we also have the conventional ETL pipelines which curate out the data so that all the other users have the right clean data to work on. So taking a step back, we initially operated in a B2B business model wherein we were connecting businesses or resellers were placing orders on the behalf of customers. Back then, we were a team of a handful, a single-digit number of data engineers, and back then we were able to solve all these use cases by having a data warehouse-based architecture along with the third-party data platform. This was able to solve the needs at that point of time. But as we scaled further and the business scaled from a B2B model to a B2C model, we saw that there are multiple drawbacks or serious drawbacks in the older architecture. There was the amount of concurrency that the data warehousing solution of back then supported was limited in nature. And that same concurrency limits, we had to cater to all the different consumption use cases which were ever growing in nature. Back then the data warehouses, the storage and the computes were tightly coupled. So with increasing amount of data that comes onto the data warehouse, we had to increase the compute, which resulted in increased costs. This resulted in us purging out the historical data, which inhibited out the analysis that can be done on the historical data. We had, in our scaling journey, we saw that we had multiple night outs, debugging and resolving out the different issues that we were facing out in in scaling out this data warehousing solution. This led to finalizing out the basic tenets to evolve towards the next data architecture that we wanted to pursue. Some of the tenets were that we wanted the platform to scale horizontally, and the scalability should not come at exponential cost increases. It should be done in a way so that the platform is scaling in an optimal manner. We should have predictable data freshness and data quality guarantees for the consumers. And the next data architecture solution should ensure that different teams are able to collaborate and utilize data in a manner so that we are able to derive maximum business values. So in a nutshell, we, based on multiple POCs and the learnings that we had, we moved from a third-party data platform and a data warehousing solution onto a cloud-agnostic data lakehouse architecture, which was powered by an in-house data platform solution that we built out. So this is a conventional ingestion piece wherein we have multiple users who are accessing Meesho via different interfaces on the web or via different apps, and these are varying in 100 millions. Now, this data gets ingested onto our ingestion service. From the ingestion service, we write this data onto messaging queues, and then we run ETL pipelines which adds this data onto the data lake. Sounds simple, and based on the older data volumes and the kind of scale, we were able to solve it via a conventional Java, Spring Boot, and a Tomcat-based application. But then we saw that the kind of limits that we can take this particular architecture to was limited to, let's say, just 350,000 RPM at every instance level. And we wanted to achieve more. We were also not getting reliable latencies with this older architecture. Hence, we moved from an imperative programming approach to a reactive programming approach. As a result of this, all the calls that we made in this service were non-blocking in nature. And we were able to scale almost 3 to 4x kind of load at every instance level. Now we were able to handle almost 1 million requests at every instance level and at reliable latencies. And we could do this in a cost-efficient manner. We were able to do this at almost 50% lower the cost. So what happens after ingestion? We run our ETL pipelines. And theoretically, we want the extractors to read data from the messaging systems, write it to a raw store. We follow a medallion architecture of the data lake. So the raw store is the bronze zone, from which the transformers and loaders run. The transformers run based on configurations which are available to different users in a self-servable manner itself. These transformations run in the jobs and add the data onto the enriched table layer in the silver layer. Now, there were multiple challenges in the legacy ETL system that we had. And these are all engineering challenges which I'm going to speak about today. We had huge dependence on the messaging system in terms of processing out in terms of scaling out the extractor workload. We were constrained in terms of the number of partitions that were there in Kafka, and like I mentioned, the kind of spikes that we see in our workloads, we weren't able to, we all know like scaling messaging systems or Kafka could be a nightmare in itself. So that was one problem statement. The other was we had an architecture wherein the intermediate layers were again being written onto the messaging system itself. We were processing the event data in a sequential manner in the event groups that we had created. This again led to the jobs running in a suboptimal manner. We also noticed that there were redundancies in terms of the IOs that we consume because of the architecture that we had chosen. And we had extra hops in the layer itself. So first thing was to take the scaling onto Spark rather than being dependent on the messaging system itself. We achieved that by tuning out the Spark clusters. This led to a lot more reliable utilization of resources. We didn't have any more nights wherein we had to repartition out and rescale out systems. We saw that again messaging systems are problematic for handling out the intermediate layers. So we moved from a messaging system to a distributed cloud storage like S3, so that we are not constrained by the bandwidth limitations that are present in messaging systems, at least for the intermediate layers. This led to improved parallelism and better utilization of resources. The event processing that we were doing in a serialized manner was parallelized, which led to better utilization of resources. This also improved out the data freshness that we encountered. There were multiple unwanted hops which we built initially to ensure that there are failure recovery and retry mechanisms. We saw that we could probably build out or retry it out right from the raw store layer itself. So we removed out these additional hops. This resulted in reduction in the SLAs, and the processing overheads were also reduced. Deep diving into the consumption side, we all know like having all the data available, but not being able to generate the right kind of insights is a nightmare in itself. So we also had to design the consumption in a way that it is scalable in nature. So we went to the data, as you know, on the storage side, we had a data lake-based architecture wherein the data is present on S3 in a data lake format, so that we are able to run the operations in a transactional manner, and we are also able to replay or go back into the logs if we have to. From an authorization layer perspective, we utilize our Apache Ranger. On the compute side, we use MPP engines like Trino, Presto. We also used Spark, and on the interfaces which provide access to different users, we use Metabase, which is an open source BI tool. We use Zeppelin, which is again utilized out at Misho for the exploratory analysis that different data scientists and analysts do. And then we'll deep dive more into the Prism platform that we built, which also allows running out the multiple analytical data models that power different products at Misho. So Prism is we took a platform approach to solving problems. taking a long-term view on how we were scaling, how we were evolving out. We saw that in the third-party platforms, the scaling that we could achieve and the deep dives when required were limited in nature. Hence, we thought that in-house is the right, building an in-house platform is the right way to move ahead. So, on the consumption side, we built out a framework which allows the users to run their data analytical models, which are basically queries that are running in a scheduled manner based on our dependency graph. We had support of different write mechanisms, right from upsert, append, and different write methodologies. We were also able to provide out different validations so that the analysis can be done in a highly productive manner. The data could also be run the queries could be run so that and be delivered as reports over email, over G Drive, over multiple interfaces. And we made the platform to be the compute layer agnostic, so we can decide on whether we want to run the queries via Presto or via Spark. We also provided a way for users to onboard out their custom Spark jobs, which required huge amount of data lifting. Now, this is how we cater out to the business analysts. On the data lake side, the data science team was able to read the data on their Spark jobs, on their feature engineering jobs. But what about backend applications which are relying on the data platform to run their data products? For this, we again built out a custom jar, a custom library, a custom framework, which is backed by a proxy server. This proxy server enables out to, and the jar enables out to choose the right query engine based on the different workload. We were able to add the right authentication, the right governance mechanisms in place for the access to the data lake. From a Prism framework perspective, we ensured that the query is simple. It is so that it is usable. We add, like I mentioned before, we added out all kinds of validation so that we don't run queries which probably block, because of one user or one workload, we block the other workloads. Which is done by the right separation and automatic figuring out of the right cluster to run a particular workload into. We were able to auto-scale out in a predictable manner based on the usage patterns because of the granular control we had as a result of the platform and as a result of the framework. The resource allocation and access controls, we were able to build out all kinds of role-based access control onto the system so that we are able to limit out the access to sensitive data. We also had great amount of observability in terms of what is happening with the data pipelines. The same Prism framework was able to input out the different ETL configurations as well, and also the different data models or the ELT jobs as well. This led to better cost utilization, better cluster utilization, and better user experience for the different analysts, for the different backend teams that interacted with us. So this is where we ended with. From the ingestion side, we also had Debezium. We spoke about the ingestion service and the scaling challenges. For the Debezium layer handles CDC for all the backend databases. for corresponding to all the services that are microservices that are there in Meesho. We were able to handle out external analytical systems also feeding the data onto the same data lake so that we are able to process and do analysis across these different data sources. Even internal sources could write onto the data lake via the messaging service that we had. Kafka became an important component itself. Everything, the real-time nature of processing was driven on the basis of Kafka. On the ETL side, like we discussed, we did multiple optimizations, and all this is based upon the data, the metadata that comes from the metadata manager layer, which is again part of the Prism platform. The storage side was on S3. It was infinitely scalable. We were able to handle petabytes of data. On the compute side, on the consumption side, we had Trino and Spark. And on the interfaces side, we had Zeppelin, Metabase, and a custom-built SDK. And to orchestrate all the jobs, we use Airflow. As you can see, we use a lot of open source components so that we are cloud agnostic and we can scale across. We have better community support. So that's the data architecture journey that we had at Meesho, via which we are building out an experience for billions of Indians so that e-commerce is democratized out for them. I would be happy to answer questions.